Hello, grade 12. We're going to continue with the questions from the question paper June 2021 done in the Northern Cape. Okay. Now, question 8. Last time we did question 7. We're going to go to question 8. Question 8 is about rate of reactions. Right. Now, question 8 states how the calcium carbonate reacts with hydrochloric acid according to the following balanced equation. And you have the balanced equation for the reaction between calcium carbonate and hydrochloric acid. The mass of the calcium carbonate, CaCO3, after every 10 seconds from the start of the reaction is indicated in the table below. There you have a table where you have in one of the rows time in seconds, so starting from 0 and going to 80 seconds, and at the bottom you have the mass of calcium carbonate in grams. Okay, we know that at 0 time we don't know the mass of calcium carbonate. That is the initial mass of calcium carbonate. Now, the initial mass of calcium carbonate is X grams. So, means we don't know what was the starting amount of calcium carbonate. Now, they say use the information in the table to identify the excess reactant, chose from calcium carbonate or hydrochloric acid, and then give a reason for the answer. Now, let's go to the solution. Solution 8.1. We have to identify the excess reactant. Remember, you have two reactants. One of them is calcium carbonate, the other one is hydrochloric acid. One of them is finishing phase. Now, we have to go to the table. We have to go to the table and see what happened with time for the calcium carbonate. When the time is 60 seconds, then the mass of calcium carbonate stop decreasing, which means state 40 for the rest of the table. That means that right here the reaction was done. However, when the reaction was done, we still did have some calcium carbonate, which means that calcium carbonate is in excess. The hydrochloric acid was done. That is why the mass of the calcium carbonate stopped decreasing right there and stayed constant. So the limited reagent is, or the excess reagent is the calcium carbonate. I'm going to write CaCO3. Right? The question said use information, give a reason for your answer to identify the excess reagent. This one, why? We have to say at the end of the reaction, there is some CaCO3 calcium carbonate left. All right, you go to the table, you see the reaction finish right there. The reaction ends there, and then for the rest of the time we were measuring the mass of the substance, they stayed constant. We still have 40 grams of calcium carbonate left. So that is the excess reactant. Here is very straightforward marking. 1 mark for identify, 1 mark for the explanation. You get 2 marks for that question. Okay. Now, question 8.2. 8.2, the same, the average reaction rate for the first 30 seconds is 1,07 grams per second. Now we're working for the first 30 seconds. So we're working, and let's mark, perhaps we mark in order for us to know where we're working. We're working for the first 30 seconds. So we're going to use this data up until 30 seconds. Okay. Now the question says define reaction rate in words. Right. So what is reaction rate in words? 8.2.1. Reaction rate. There is a video done. I will leave the link in the comment in the explanation of this video. I will leave the link so you can go to the next video in terms of reaction rate. Reaction rate is the change in concentration concentration. Let's write the concentration here at the bottom. In concentration of reactant or product per unit per unit time. Right? That is the definition of rate of reaction. We can always write the formula. Rate of reaction is equal to the change in concentration of reactant or product per unit time. It can also be calculated by the change in mass per unit time, or even the change in number of mole per unit time, or change in volume per unit time. So any of those could be used to calculate the rate of the reaction. We're going to use the definition. It's the change in concentration of reactant or product per unit time. All right. So let's go. Here is to mark for the definition. It's to mark for this definition. It's 2. So let's go to 8.2.2. 8.2.2, and they say calculate the initial mass X of calcium carbonate. Remember, we're working with this time for the first 30 seconds, and then the rate there is going to be equal to 1,07 grams per second. Okay, so we're going to see in the table we have mass, so we're going to use the formula for a mass. Okay, now there is something very important here. Let's write the formula. Rate of reaction is equal to change in mass divided by change in time. But the mass in this situation is decreasing, so it's going to be a negative change in mass. It's going to be negative because there is a decrease in the mass of the reactant. If it's an increase, it's a positive change. If it's a decrease in mass or volume or number of mole, it's going to be a negative change. So if we go back to the formula now, then we have that rate is equal to minus. Remember, change is final mass minus initial mass divided by change in time. Final time minus initial time. Now, remember once more, be careful with the minus there. The minus is because it is a negative change. It is decreasing in mass. All right. So we can now do the substitution. The rate was 1,07. 1,07 is equal to minus final mass is 54 there. It's 54 grams minus X, that is what we're looking for, divided by the time. The final time when the mass is 54 is 30 and the initial time is 0. So it is 30 minus 0. Alright, so when you solve this one, it's very simple math. 30 minus 0 is 30. So this will be the product of 1,07. Let's fix that number. 1,07 multiplied by 30. And that is equal to minus 54 plus X. You open the bracket right there. This is a fixed 54. Let's fix the number. 54. Okay, so now let's quickly do the calculation so you can see it. It's 1,07. This is 1,07 times 30 equal to 32,1. This is 32,1 plus 54, and that is equal to X. All right, 32,1 plus 54 plus 54, we get 86,1. So X is equal to 86,1 grams. That was the initial mass of calcium carbonate at the beginning of the reaction. The mass allocation here are 1 for the substitution of the 1,07, 1 for the substitution of the mass, the negative should be there, and 1 for the substitution of the 30. Final mark is for one of the answers. There is 4 marks for this calculation. I hope it is clear for you all. Okay. Now, question 8.3. Question 8.3 said, use the collision theory to explain why the average rate of reaction decreases with time in this reaction. Now, before to that, let's go to 8.3. Now, before we go on, let's recall quickly, and this is obviously not part of the question, but let's record what are the factors that affect the rate of the reaction. So first of all, concentration. Second, surface area. Remember, this is only for solids. Third, pressure. This is only for the gases. Okay, so we have concentration, we have surface area, we have pressure, we have temperature, we have catalyst, we have a catalyst, and we have nature of reactant, which I'm not going to write there. Now, from all these factors, we have to identify which one is the one that affects the rate of the reaction in this situation. All right? Now, here, what is happening as time passes? What is happening? Okay? The concentration of the hydrochloric acid is becoming less because it's being used up. So the concentration is the factor that is being decreased here. So you have to write to answer this question. This is the factor that is going to be dealing with in this question. Okay? I will write. As time passes, the concentration of the hydrochloric acid decreases. As time passes, the concentration of hydrochloric acid decreases. It is being used up. Alright, that is the first thing. Second, that I will say, a decreasing concentration of hydrochloric acid decreases the number of molecules per unit volume. And here you will get the first mark. You will get 1 mark for saying that one. Okay? What happened? The concentration decreases. And when the concentration decreases, therefore there will be less number of molecules per unit time. What will happen when there is less molecules per unit time? A decrease in number of molecules decreases the number of collisions. Number of collision decreases, therefore, and that is the final one here, therefore the number of effective collision, let's fix the word collision here, effective collision per unit time decreases. And so the rate of the reaction also decreases. Those are the last 2 marks. So one for saying that the average number of collisions decreases, therefore the number of effective collisions per unit time decreases. And important, effective collision per unit time. That word must be in that specific way. All right? So that is the last mark. This is the question. I think it's a quite easy question. There is 3. Let's finish here. There's 3 marks for this one, and then the total for this question is 11 marks. I think this question is a very easy question, easy to get marks. However, they were not well answered during the examination. Okay, thank you very much. I hope it helped. I hope it's more clear for you. Next time we'll go with question 9, which is equilibrium, quite difficult. Please try to watch the video once more. I always recommend you to answer the question before you watch the video. Use the video to mark the question. Thank you. See you next time.